uh, we have to discuss the satellites near the surface of Earth. Actually, these are known as the baby moons or spitting satellites. They are very near the surface of Earth. Their height varies from 50 kilometers up to 200 kilometers, you can say, or 400, whatever the distance, but they are very near the surface of the Earth. And suppose if this is the Earth, and this Earth, and its mass of Earth is suppose 6.0 into it is 6, you can take 6.0 into 10 power 24 kg mass of the Earth, and this is its radius of the Earth is 6.4 10 power 6 meter. Around this radius, very near to the surface of the Earth, a satellite of mass m revolves around it with linear speed v, angular speed omega, and it has a time period t. We have to find all these: linear speed, angular speed, and time periods. So let us see. Here we will take the orbital radius r, which is almost equal to radius of the Earth, for obvious reasons, because this distance is very small as compared to this one, which is a very huge distance of 6,400 kilometers. So let us see first how I calculate the angular speed. Angular speed is calculated using the Golden equation of satellite. The Golden equation says mr omega square is equal to gmm upon r square. M is cancelled with m, omega square coming out to be gm upon r cube. Now put the values. If you put the values, g is 6.67 to 10 power minus 11, mass of Earth is 6 into 10 power 24, r cube is 6.4 into 10 power 6 whole cube. Now let us calculate omega square. First you will be calculating omega square, then you will be calculating the omega. So omega square coming out to be 6.67 exponential minus 11, 6.67 exponential minus 11 into 6 exponential 24 divided by 6.4 exponential 6 cube, and it's coming out to be 1.5266 into 10 power minus 6. So omega is the square root of this one. Square of this one coming out to be 1.24 into 10 power minus 3 radians per second. So the satellite, which is near the surface of the Earth, has almost angular speed of 1.24 into 10 power minus 3 radians per second. And how it is to be found? Very easily. mr omega square is equal to gm upon r square. M is cancelled on both sides. So angular speed does not depend upon the mass of satellite. So m cube omega square is equal to g upon r. To put the values, this orbital radius is almost equal to the radius of the Earth. So it's coming out to be omega square. This is omega is 1.24 in 10 power minus 3 radians per second. Let us see now how I calculate the time period of such a satellite. What's the time period of such a satellite, and how much time it takes while revolving around the Earth. So time period of such satellite is, I can say, t is equal to 2 pi upon omega. So put the values. T is equal to 2 into pi is 3.142 upon omega is 1.24 into 10 power minus 3, and it's coming out to be 2 into 3.142 divided by 1.24 exponential minus 3, and it is coming 5067 seconds, or if I write in minutes, I have to divide by 60. It is coming as 84.46 or 84 minutes. So roundabout it takes from 80 minutes to 90 minutes. So its motion, these satellites almost take 1.5 hours to complete, to have the complete round trip around the Earth. So how I calculate the time period t upon omega? I have calculated omega. Omega is 1.24 10 power minus 3. Just put the value of omega here and get it's almost 84 minutes. Now let us see what is the linear speed. Linear speed must be very, very high, because it is taking only 1.5 hours to complete move around the Earth. So its speed must be very high. Let us see what speed is. It's the linear speed. I want to calculate the linear speed of such satellites. Now linear speed v is equal to r omega. R is orbital radius, which is 6.4 into 10 power 6. Omega already we have calculated 1.24 into 10 power minus 3. If you calculate this, it is coming 7,936 meters per second. I can write 7.936 kilometers per second, or this is nothing but 8 kilometers per second. It's a very, very huge speed. It means the satellites which are near the surface of the Earth, they move around 8 kilometers in an average second. So that's a very huge speed. That's why they cover entire Earth in 1 hour and 30 minutes, or 80 minutes to 90 minutes almost. So in these times, although I have taken here the height of the satellite is 0, but it's not height of the satellite which is 0. Almost I have taken the orbital radius equal to radius of. These are satellites which are near the surface of the Earth. If the radius, the height is given, suppose examiner says the height of a satellite is 400 suppose kilometer. So you will be just adding 6.4 into 10 power 6 plus 400 to 10 power 3, and then get the orbital radius and check the calculations. So you can take this chapter also. But clearly, I have not given here the exact value. I have just calculated the approximation values here. And suppose for other uses of these satellites, first of all, because they are near the surface of Earth, so they are very suitable for a spying purpose. Also for communication purpose. Okay, for communication that does not last for longer time. For cricket, these are not proper for that one. But for short messages and for short transmissions, that's okay. And it's also used for the weather forecast for all around the world. Or also, so these satellites are near the surface of the Earth. They are used in that way. Their linear speed is almost 8 km per second. Their angular speed is 1.24 in 10 power minus 3 radians per second, and their time period is almost 85 minutes or 84 minutes, or from 80 to 90 minutes, I can just say.